Chapter 7 review is the last video you have to watch for the year. So yeah, you can celebrate big time. We'll go through it. Remember, this is just a review video, which means we're not going to cover everything we talked about in class in each of the 2 sessions of Chapter 7. If you have anything you're uncertain of, go ahead and look at the small videos. Go back to whatever subchapter you need to and get the information you need out of there. For now, 7.1, we talked about rational roots and n roots. What if we have to do 7 to the negative 2 over 3? There's a long way, there's a short way. The long way is, that's a negative exponent. My marker doesn't work. 1 over 27 to the 2 over 3, or 1 over, we have a root. The bottom comes in here. The top goes in there, right? We said the bottom of the fraction tells us what kind of root we have. That one is just the exponent on the inside. You're going to go 1 over cube root of 27 squared, which is, I don't know what it is, 7 something. 27 times 27, 729. And then you're going to put that in your calculator. Quick review. Math, option 4, right? Go down to option 4. I did enter and I put 729. I hit enter and I get the square root of 729 is 9, the cube root of. So this is 1 over 9. Okay. Here's another type of problem that we did in here. If n is 6 and a is 64, what is n root of a? Or what is 6 root of 64? We did this using a calculator again. We're going to do math. Go down to option. Actually, we're not going to do that. We're first going to put the kind of root we need. We're going to do 6, then math, then option 5. Then you hit enter, and then you put 64. So basically, you're telling the calculator, I need the 6th root of 64. We hit enter, and we get 2. However, if you're just going to write in there it has 2, you're going to lose points, because we said when n is even, we get a plus and a minus. When n or that root is odd, we only have one solution, whatever the calculator gives us. So once you work this in your test, on your review right now, look at this, and as soon as you see that's all even, put a plus and minus, then do your calculator work. I'm going to let you pause. We're on page 456. I'm going to let you work 1 through 8. I don't care that you use a calculator. It says do not use a calculator. Whatever you want to do. If you think it's going to be easier with a calculator, use a calculator. And then come back. Okay, guys, here's your answers. For 1, plus and minus 2. For 2, 16. For 3, 1 over 243. For 4, 6. 5, negative 2. 6. Plus and minus 3, 7, negative 1, 8, 0. If you need to, go ahead, pause right now. Make sure you got the answers right. See if something did not work good for you. And then we're done. We're going to move on 7.2. Please remember to keep your exponent properties next to you. However, as I told you many times during chapter 6 and 7, it will help you if you have them memorized. What if you do cube root of 3 of 12 times cube root of 3 of 4. If it's the same kind of cube, if the same kind of root, in this case it's a cube, I can write this as 312 times 4, which gives me cube root of 48, and we do not leave it here. This is your little tree coming in. This is 2 and 24. This is 2 and 12, 2 and 6, 2 and 3. Is this right? I think it is. I'm not 100% sure, but I think it is. Yes. And we said in order to get one thing out, we need to have 3 of them. Well, here it is. I have 3 2's. 1 can come out. What stays in? A 2 times 3, or a 6. This is how we reduce radicals. That number that tells you what kind of root it is, it's also going to tell you how many of the same kind you need in order to pull one out. This was a 3. If it would have been a 4, we needed 4 of 2's to pull them out, right? Let's look at another example. If I have x to 1/2 y, and all of it raised to the 2nd power, over x to 1/2 y to 3/4. Again, this is just property of exponents, the list of that. This 2 gets distributed, right? The top becomes x. 2 times 1/2 gives me 1. Y to the 2nd power, all over x to 1/2 y to 3/4. I can separate this. x over x to 1/2 times y to the second over y to 3/4. Why do I want to do this? Because this is the same base, right? This becomes x to the 1 minus 1/2 times y to the 2 minus 3/4. And I told you before, should you need to do this, you can do this using a calculator. You don't have to stress with fractions if you don't need to. Y to 1/2, and then, no, x to 1/2, sorry. Y to 5/4. When you do 2 minus 3 divided by 4, it gives you a decimal. You go to math, option 1, you write as a fraction, and you get 5/4. Okay? So this is kind of like what you're going to play with this under 7.2. Page 456, go ahead and pause. You're going to work 9 through 16, and then you're going to come back and check. Okay, guys, I'm here. Here's your answers for all of them. 9, it would be 1 over 5 over the second, or 1 over 25. 10 is 100 to 1/4. 11 is root 3 of 2 over 5. If you're wondering why, it's because when you separated, root 3 of 1000 is 10. Use a calculator to make sure what that is. But this 16 can be written as 2 times 2 times 2 times 2 can be reduced. I can pull a 2 out, 1 stays in, and then 2 and 10 reduce, right? So pay attention, never leave it without reducing radicals. On 12, you get 1 cube root of 17. On 13, you end up with 81 to 1/4, x to 1/4. Do not leave it that way. 81 to 1/4, put in your calculator, is actually 3. We leave it the way it is only when we put in a calculator we get a decimal. If we get a whole number, we don't leave it that way, okay? 14, you end up with 4 to the 3 over 2 times x to the 3 over 2. But 4 to the 3 over 2 is actually 8. If you put in your calculator, x to the 3 over 2. 15 wasn't that difficult. You had 6 x's, 1 could come out because your root is 6. You had 7 y's, 1 came out, 1 stayed in. You had 10 z's, 1 came out, 10 minus those 6, 4 stayed in, and then the 6 just stayed in, right? This is your answer. X, Y, Z, 6 root of 6 y z to the 4th. 16 I solved for you just for you to see how it works, right? We had an a to the 6. This is a cube root. I can pull 1a out. I'm still left with 3. I can pull 2 a's out, right? So that becomes a squared, cube root of 4. 4 cannot come out. Underneath here, I already had an a to the 3rd. This is a cube root. That a can come out. Again, I have an a squared. And then cube root of 108. 108 can be written as 3 times 3 times 3 times 2 times 2, which means 1 3 can come out. I end up with 1 apple plus 3 apples. I end up with 4a squared cube root of 4. If you need to pause it and see what I've done here step by step so you understand how we got there. Keep in mind these were 3, so they can come out. Makes that a square. These are actually 3 and another 3. There's 2 of them coming out. That makes it an a squared. And that's about what we did in this chapter with exponent rules. We're going to move on to 7.3, which dealt with operations with fractions of functions, adding, subtracting, multiplying, and dividing functions. So let's say that we have f of x is x to 1/2, and then g of x is x to the 4th. Let's add them. Let's say what is f of x plus g of x. Then we're going to do what is f of x minus g of x. Then we're going to do f of x times g of x. And then we're going to do f of g of x. This is a composition. We'll go through all of them and see how they work. When I add them, I literally just add them. This becomes x to 1/2 plus x to the 4th, or square root of x plus x to the 4th. And that's where we leave it. We don't mess with it at all. You don't even have to write it as, oh, this has a 2 in front of it. I'm sorry. So we don't even do this. That's it. We just add them up. When we subtract them, same thing. 2x to 1/2 minus x to the 4th. And you're done. That's how we subtract two functions. Sometimes you can combine terms. When you can combine terms, you're supposed to. But here I can. This is an x to 1/2, and this next to the 4th. It's like apples and oranges, right? What if I have to times them? This becomes 2 x to 1/2 times x to 1/4. This is where the exponent rules comes in. 2x to 1/2 plus 4, or 2x to 9/2. Okay, you can do that in a calculator, make it as a fraction. You're good to go. Now, when I have to do it, I'm looking to see what composition they did. They did it like this. This becomes my f of g of x starts with 2, and instead of x, I'm actually going to use x squared, x to the 4th. That's my g of x. And then I raise it to 1/2, right? So instead of just putting whatever it's in there, which is an x, I'm going to replace it with what g of x is. So this becomes 2x to 4 times 1/2. This is one of those properties. Or 2x to the 2nd power. This is how we add, subtract, multiply, and compose two different fractions. In order to make a composition, you keep whatever is a constant, but whatever is x, it gets replaced with whatever your second function is. I'm going to let you pause. You're on page 457. You're going to do 17 through 21. Okay, guys, here's your answers for 17. 3x minus 6, 18, x minus 2. 19, we did FOIL, 2x squared minus 8x plus 8. 20 was tricky. If you just stop right there, you kind of missed the point, because if you look on the top, you can factor a 2 out. I pull a 2 out, I'm left with x minus 2, which reduces the 2x minus 2's. And really, my final answer is just a 2. So don't stop there. You're going to lose points in your test. You always have to make sure that you can not factor anything else out. 21, f of g of x becomes 2x minus 8. And I kind of had them worked out on the board for you to look. We're going to move on to inverse functions. And we said whenever we do inverse functions, all we do is we switch the x with the y and then solve again for y. If I have y equals 2x, is it plus 5? It's minus 5. And I want to find the inverse of this function. All I have to do is go x equals 2y minus 5. And now solve again for y. You know me. I'm going to move my x on the other side. Plus 5 divide by 2. The inverse of that function is y equals x over 2 plus 5 over 2, or 1 over 2x plus 5 over 2. That's how you find your inverse, right? You switch them, and then how do you write this? If this is f of x, that looks like this. This is going to be f to the negative 1 of x. That's the symbol for the inverse. It's f to the negative 1 of that function, okay? Now, how do we know if two functions are inverses of each other? Well, if I give you two functions, and I do the composition both ways, and I end up with x, that's how I know that is correct. So, let's work with these functions. I have f of x equals 2x minus 5, and I have g of x that equals 1 over 2x plus 5 over 2. And I want to know, are these two inverses of each other? Well, let's do this. F of g of x equals 2 times 1/2 x plus 5 over 2, right? Instead of x, now I'm putting my g of x, minus 5. We'll end up with 2 times half is 1x. 2 times 5 over 2 is 5. Minus 5, there you go, I end up with x. Let's see the opposite. What if I do g of f of x? To see are they inverses or not? 1 over 2, parenthesis, 2x minus 5. Instead of x, I'm now using f of x because I'm doing the opposite composition, plus 5 over 2. We're going to do the distribution. 1/2 times 2, 1. I end up with x minus 5 over 2 plus 5 over 2. This is just your distribution, guys, right? I end up with x. Yes, the two functions are inverses of each other. Why? Because when we compose them, they both equaled x. I'm going to go ahead and let you pause the video. We're on page still 457, 22 through 25, and come back. Okay, guys, here's your answers for 22, negative 1/2 x plus 1/2, or you could have had a negative x over 2 plus 1/2. For 23, you either got negative x to 1/4 or 4th root of negative x. For 24, your y should be cube root of x minus 7 divided by 5. 26, the answer is yes, they both equal x. If you need to see how I work them out, you can pause the video, okay? We're going to move on to graphing cubes and squares. We're not going to freak out about this at all because this is a calculator work. What if we want to graph this? Y equals cube root of x minus 5 minus 2. And really in your test is going to ask you to tell what is changing. So we've talked about this. The number inside here tells me what it moves vertically. The number on the outside tells me how it moves vertically. So from here I already know it moves down 2 and it moves right 5. If you remember, we talked in class when we learned this, that this sign will do the exact opposite of what you're thinking. When you think negatives on a thing, you're thinking left. That means this graph is moving right 5 units. Other than that, I don't really mind you doing a calculator work. We're going to go to y equals. We're going to clear everything out. I have a lot of stuff there. And now we're going to do math. Go to the cube root, option 4. I'm going to put in that parenthesis x minus 5, close parenthesis, go out, and minus 2. Okay, this is it. And we're going to always do zoom 6 because we want to do that. We want to get a clear graph of what we're doing. Here's our graph. And as we talked before, really, I just want you to, the best of your abilities, graph it relatively correctly. So my graph was going to look like this. Right? Don't scribble it, but I don't need the values of it. I just need to know that when I graph it on my calculator and check your work, they look very similar, okay? But I always want you to tell me what it does. It moves up, it moves down. Remember, if this would have had a negative in front of it, you would have added this reflection over x axis, right? Please remember that part. So I'm going to let you go ahead and, they also wanted us to say domain and range. When you look at cubic and generally cubic functions, their domain and their range are all real numbers at every single time. Now, if it's a different kind of function, if it's a square function, then your domain is going to be most likely greater than 0. So x will be greater than 0. But anytime you have a cubic function, my domain is all real, my range is all real. If you manage to remember this for your test, as soon as you see that little 3, you can name the domain and the range. The other way to look at it is, can I tell where my x starts and ends? No, it's all reals. Can I tell where my y starts and ends? No, because this continues, right? If I zoom out, just as a thought process really fast, if I zoom out and make this smaller, it keeps going, right? That's how we know it's all reals. If I would have to just graph for the sake of it, let me do this. If I would just have to do a square root of x, let me close parenthesis, plus 2, and I would graph that square root just for you to see. You see how my domain stopped? My x, I can tell it starts at 0. There's no other way around it. Now my y starts wherever that thing is, and my domain starts at 0 because that's where x is. X is 0. So go ahead and pause the video. We're going to work 26, 27, 28, and 29 and come back. Okay guys, I'm not even going to bother with the graph. I'm pretty sure you graphed them correctly. I will show you the book in a second. But for 26 and 29, your domain is all real, right? They're cubic functions that will never end. For 27, your range is greater than 0 and your domain is greater than 0 and your range is greater than 6. And remember, when we have something like this, square root of x plus 3, that 3 tells you where your range starts. In this case, you had a plus 6, right? So that's what my range started at 6. On 28, your domain is great. X is greater than 0. Your range is y is less than or equal to 0. When you graph them, these are the graphs. I will put this as close as I can for you to be able to see them. Here they are. Okay, we're getting there. So you can pause the video right now so you can see this image. Or you can just look at them and go, I got it. Remember, I don't need all those dots. I don't need the exactity of the graph. I just needed to know what the graph looks like and be accurate. Now we're going to flip the page. We're moving to 7.6, which is solving radical equations. They don't have a hard one in there, so we're going to work an extra one before I let you work on your own. But if we have square root of x minus 4 equals 6. These are the easy kinds, right? Well, I can't do anything, but I can square this, because if you remember, we don't put it in there, but there's a 2 in there at all times. This will cancel that, but if I do it on this side, I have to do it on this side. X minus 4 equals 36. I move my 4 over. X equals 40. And if you remember, this type of problems, I told you, you don't have to check them. They will tell you check for extraneous solutions. Whenever you just get one solution as your answer, you do not need to check, as long as you did the math right, okay? It's whenever you have two solutions, when you're going to have to end up factoring, that's when you check for extraneous solutions. And you do have to check it. If you remember, I taught you how to do this the easy way, okay? And we'll do one just so you know what we're doing. The second example will be 4x to the 2 over 3 equals 100. Is it 100 really? Yes. I divide the 4 out. X to the 2 over 3 equals 25. I need to get rid of that exponent. I times with its reciprocal. But that means I'm going to have to put the reciprocal there too. X equals, and if I used to this and I go to clear this out and I go 25 raised to, and remember that is a fraction. I'm going to open parenthesis, 3 divided by 2 and close my parenthesis. My answer is 125. So we talked about this many times. When your exponent is a fraction, please put it in parentheses. So my answer is 125. Let's work one that has extraneous solutions, because I do need you to know how to work that out and how to figure out how does that work. Well, I need to come up with one, don't I? That's not going to help us much. Let me see if we have one in here that tells me that. Yes, here it is. Square root of 5x minus 7 equals x minus 1. Also, this is 3. It's good to know, so we actually get good solutions, and this is a plus. I made up some numbers. The only way to get rid of that square root is to square it, right? Remember, there's a 2 in there. If I bring it to a 2, I get rid of it. But if I do it to this side, I need to do it to this side. On this side is easy. 3x plus 7 is on my right, correct? On my left, this becomes x minus 1 times another x minus 1, if you want to do FOIL. If you remember the formula, you just follow the formula, which tells you it's x squared minus 2x plus 1. If you don't, you just go outers, x squared, in first, x squared, outers negative 1x, inners negative 1x, which brings it to negative 2x, and last, positive 1. Now I need to move everything on the other side to equally to 0. So I'm going to go minus 3x minus 7. I end up with x squared minus 5x minus 6 equals 0. Okay, this is the factoring situation that we're talking about. X and x, a positive and a negative, because both numbers are negative. And I'm thinking of two numbers that times to negative 6 and add to negative 5. Negative 6, positive 1. When I times them, I get negative 6. When I add them up, I get negative 5. Which means I either get x equals negative 1 or x equals 6, right? 6 minus 6, 0. Negative 1 plus 1, 0. How can I tell which one of these solutions is extraneous? Well, one of them will be to plug it all back in and figure it out. The other way is 3x plus 7 equals x minus 1. This was your original equation, right? And I want to keep reminding you how to use your calculator correctly. If we go to y equals and clear, and for my y1, I'm going to use just this part. Second square root of 3x plus 7, close my parenthesis. I'm going to move down to y2, and I'm going to put there x minus 1. So now I have two functions, right? And now I'm going to go zoom 6. I'm going to let them graph, which they're going to do. There's my square root, there's my line, and now I'm going to tell them I want to know where they intersect. Clearly, they only intersect in one place. So clearly, one of these solutions is extraneous. Just by looking at it, you should know that x equals negative 1 is out, because x equals negative 1 is right there. They don't touch. But let's make sure we're right. We go second, calc, and option 5 says intercept. I got 5. They're asking me on the top, is this your first curve? And we say, yes, it is. It actually does a very good job at identifying your curves. Then it's going to go, is this your second curve? And I go, yes, it is. And it's going to ask me, do you want me to guess it? Yes, I do. When we guess it, the only solution we have here is x equals 6, which tells me this one is out. So you don't have to do the work doing it by hand. You can do it by calculator. Plug the first one as it came into your book. Plug the second one, see when they intersect. That's your solution of the problem. I'm going to let you pause the video. We're on page 558, and you're going to do 30 to 32 and come back and check. Okay, guys, here's your answers. 30, your solution is 31, and I solved it for you. On 31, if you remember, we first had to move the square root of a cube root of 4x on the other side. Once we moved it and we have two roots on each side, then I can cube it and get rid of both of them. The answer is simply -3. And then on this one is the one with the extraneous solution. You should have gotten to an x equals 16 and an x equals 4. When you graph them, I didn't put them in anymore. Your only solution should have been 16 whenever you looked at them and you looked where they intersect. Even when you graph it, you can't see it exactly when they intersect. If you just go to second calc, option 5, identify your curves, they will still give you the right x. You don't necessarily have to see it, okay? But if you did look at it just from the perspective of the graph, you would have seen, English is hard, that they don't touch at x equals 4. Last thing is statistics and statistical graphs. There is a whole table there. It's already plugged into my calculator. Keep your sheet close by where it teaches you how to do stats and put the list in and all. My list is already plugged in there. Here's what they want me to find out. They want to know what is the mean, the median, the mode, the range, the, what is it called? Standard deviation. Okay. And we said that most of them come from the calculator. How do we do this? Once we plugged in the list, we go to stats, we go to calc. We say one variable stats, and I want to tell it I need you to work with L1. Okay? And then I hit enter. Let's see what we get in here. The first little thing, the X with the little line on top of it, that's my mean. It's 85.9 or 86 if you want to round it up, okay? Guys? No, it is. I was right. It's 85.9. I was looking at your problem, the second one that you do. The median, we said if we go down all the way to where it says med, right there, med, 86.3. They're all going to be decimals because we started with decimals, correct? The mode is the one that repeats the most. If you look at those numbers, no numbers repeat. So there's a possibility that for your mode you say none, because nothing repeats. Now, if you would have had a number that repeated twice and that was it, the mode would have been that number. If a number were repeated the five times, it would have been the most, then it would have been this one. In this case, we do not have any, okay? The range is given to us by the maximum minus the minimum. So I'll go 105.9 minus 65.9, 5.9 minus 65.9, which is 40, unless I'm crazy. What does the book say? The book says 40. And the standard deviation, I'm going to go back up there, and we said is that funky little right there, the sigma thingy right there, 14.4. So really all of this is more work putting in your listing than it is actually getting stuff out of it. Now, if I need to do a box and whisker plot, which you will have to do, okay? We're going to use our calculator again. We're going to go all the way down, and we said what we're going to do is going to be a list, a line, not a list, I'm sorry. Right in the middle, no, we're going to start with the minimum and the maximum, which is 65.9, and then the maximum is 105.9. Then I'm going to plot my median. I need my median, which is 86.3. I'm trying to think, 20. I think in this case, it's kind of like right almost in the middle. 86.3, that's my median. And then your calculator also gives you Q1 and Q3. There's the lower quartile and the upper quartile. Q1 is the lower one, is the smaller value, 72.8. The next one is the higher quartile, which is 100.3. Just so you know, all of your information is given to you in the book. Actually, it's not. You're going to have to, oh, yes, it does. They give you the The two quartiles, they're right there. Okay, and now we're going to do the box and whiskers. The box is made by the quartiles and the median, and then the whiskers start from the median and go out to the minimum and the maximum. Okay, histogram. In this case, we're going to go from 60 to 69, from 70 to 79, 80 to 89, and 90 to 99. These are the two options that I have, and we're going to go and see how many numbers do I have in between 60 and 69? Just one. How many numbers do I have in between 70 and 79? I have two. 80 to 89, 1, 2. Oh, we keep going. 90 to 99, just 1. 100 to 109. I have 1, 2, 3. Oh, I messed up. Guys, how many numbers do I have in between 60 and 69? There's 1 in January, 1 in December. This is a 2. 70 to 79. I have a 70, a 75, and a 74. These are 3. I didn't realize that they go crazy. 80 to 89. I have 1 in October and 1 in April. So I only have 2. And then the middle is the 90s. 1, 2. And for 100, I have 1, 2, 3, June, July, and August. Okay? To build the histogram, 1, 2, 3, 4, 5. I'm not even going to. We're going to start from here to here. That's my first interval, my second, 1, 2, 3, 4. Third, fourth, and fifth. My first goes up to 2. My second goes up to 3. Then back to 2. Another 2. And a 3. And that's how we do our histogram, right? We give intervals. They always tell you what you start with, and you stay within those rhythms, and then you fill everything out and you graph it. So this is the last thing you need to do. Go ahead and pause the video. We're on page 458. You need to do 33 and 34 given the data that they gave you. Okay guys, here it is. The mean for your list should be 40.9. The median is 42. Your mode is 51 because 51 repeats twice. Your range is 42, 63 minus 21, and your standard deviation is 11.3 when we round out. Here's your box and whiskers. We plot the upper range, the lower range, upper quartile, lower quartile, and your median. Right? All of those come from down here in your list, right? And then we just draw the thing. And then we did 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69. The frequency is 2, 3, 4, 2, 1, and we graph accordingly. And this kind of ends the review of chapter 7. For your test, my advice for you would be to make sure you know your rules of exponents. You can't use that as a cheat sheet. Make sure you keep the paper that teaches you how to put stuff in your calculator close to you. You're going to want that with the stats. That is your cheat sheet. You're allowed to use it so you can get all of this out correctly. And then I do not think that I'm taking anything out of this other than problem 33. Do not do problem 33. We're not writing essays. I don't need you to tell me anything about statistics on that thing. So problem 33 is out. Everything else is in. I do want you to remember one particular thing. Pay attention to problem 26. So when you solve it and you get an answer, stop and look at that answer and think about if it's the right answer or not. Okay? That's my only thing that I'm going to tell you. Pay attention 26. Look at it hard. Look at the exponent you're working with and see what you get. Happy testing and Merry Christmas and have a wonderful winter break. And I'll see you at church at some point.